Our next speaker, I met some years ago when we were running an experiment in that little trailer house, that little mobile unit. We didn't have this excellent professional facility. We were in that mobile unit. I'd spent a number of decades working on a model, the creation model. We needed to put it to the test. So we built the world's first hyperbaric biosphere. We had various professors involved, Professor M.E. Clark, University of Illinois, to name one, had various professors involved. In it, we tweaked 8 different parameters that biological systems are already accustomed to, but some to a greater degree, like increasing the atmospheric pressure to the point where the blood plasma is assimilated with oxygen, increasing the ratio of oxygen, the ratio of carbon dioxide, but especially increasing the electromagnetic field. It is now on the Earth 0.5 Gauss, 1/2 Gauss. We have academic information to conclude that it was about 10 times its current moment, that's the energy level, meaning it was just under 5 Gauss of energy, so we applied that. We ran experiments with fruit flies, Drosophila melanogaster. We have a specialist in fruit flies today. Jackson, where are you? Would you stand? He's a young man who provides the fruit flies, Drosophila melanogaster, for some of the professional agencies in the Dallas-Fort Worth area. Thank you, Jackson. Thank you so very much. I've known him since he was that size. So we ran experiments with fruit flies, and in the second generation, we tripled their adult lifespan just by having them under these special atmospheric conditions, enhancing certain things like the magnetic field, atmospheric pressure, the ratio of oxygen, the ratio of carbon dioxide. And we did what Harvard had not at that time done, and I don't think to this date has done, without giving special nutrition, just giving them the standard fare for their diet. We tripled their adult lifespan in the second generation. That's the equivalent with their lifespan. That's the equivalent of our living to be 200 years of age, even with our damaged DNA, assuming that we have our 70. So you triple the adult lifespan, you got 200 years of age. But the way things are going, Dr. Mark, I'm not sure I want to stay around for 200 years. No. All right. But we had some very special experiments going on. We brought in copperheads and rattlesnakes. I say we brought them in. I'm the director. And there's certain jobs you delegate, Keith. You looking for a job? Rattlesnakes and copperheads? That's good. He said, I'm here, send me. So we brought in the specialist. We used Agrodalus and Echidrodon contortrix. Those are copperheads and rattlesnakes. We had 40 miles away a control group, litter mates. Dr. Bowles, litter mates, that's control. And for 4 weeks, we had these snakes in the biosphere simulating Earth's pre-flood model. Simulating. Why do I not say duplicating? Because I was not here to measure it. Our colleagues were not here to measure it, so we simulated. So we simulated Earth's pre-flood atmosphere. When things got bigger, things lived longer. And in the original creation, there was no damaging effect, but that was added when man got his fingers in the pie. Okay, so we simulated those conditions, and Professor M.E. Clark came down from Illinois, University of Illinois. He had been here a number of times before, and he said, why don't you milk the snakes? I said, it's too early. I had predicted that in the third generation, we should be able to see a difference in the snake venom. Third generation of snakes. I said, it's too early. He said, well, you've had them in there a month. Why don't you milk them and find a lab and see if anything has happened? Class, many of you understand that most scientific breakthroughs have been made serendipitously. Now that's a fancy term meaning what?
Chance.
Yes, by accident, chance. I mean, we really don't know what we're talking about to the ultimate degree. We're just learning about God's creation. Okay, I'm trying to abbreviate this, but it's hard not to. Okay, I'm ready to give you the climax by introducing the speaker. So M.E. Clark, we had the snakes built. I brought a PhD in to milk snakes along with Robert Summers to milk the snakes. We took the control venom and we took the biospheric snake venom, went to the best independent certified lab we could find. The director of that lab is here today. That lab is an extension of the Texas A&M educational system. Dr. William Bowles, my dear friend, is now retired, but he witnessed the making of some history that he's going to tell you about. Would you welcome Dr. William Bowles? Would you introduce your dear wife first?
Very well, you bet. Thank you, Dr. Ball. It's a pleasure to be here today and share with you some things that we did. It's been a few years back now, but we were concerned about getting here, and my wife agreed that she would negotiate the Dallas traffic and get us out. Shirley, if you're back there, would you stand, please? There she is. Shirley, my sweet wife. Come about Thanksgiving season, it'll be 60 years.
Oh, wow.
We were just very young when we got married, you know. Well, let me say first that this research was published a few years back. It was first presented at a meeting of the association, the American Association for Dental Research. And I can hear questions of dental research and snake venom. Well, we do lots of kinds of research that the relationship is not necessarily apparent at first, but it will let us look at ways to approach things. Now, in the beginning, what was this world really like? We don't know, except we see artifacts, we see things that have been dug up, and we read the Bible description of the creation week. And one of the important factors that we look at is said that at the beginning the earth was without form and it was void. Now, without form, we still assume that it was global and it's globular in its shape, but it said that the surface was covered with water. And then it says God took that water and separated it and made a layer up in what we would say the upper atmosphere, and then the rest of it he left for oceans, puddles, whatever. So what benefit might we derive from this film of water vapor in the upper atmosphere? Turns out that water is a good absorber of little subatomic particles. We have all kinds of electronic business today, a wireless microphone. We pick up our wireless smartphones and talk to people and so on. And it's all related to radiation, particles that transmit signals, waves, intensities. And so this barrier, this water vapor barrier, protected the Earth from these subatomic particles. Some names of some of them, for whatever it's worth, of course, electrons. What's in the middle of an atom? Two main kinds of particles we call protons and neutrons. They found a few other things in there too, but those are the main ones that identify an element as being copper or aluminum or a diamond. It's the number of neutrons and protons in the nucleus that makes the difference from one kind to another. So these things coming from radiation from the sun, perhaps other sources, bombard the Earth, and when the flood came finally, that water vapor layer rained down upon the Earth. It was not the only source of water. It said that fountains of the great deep were broken up. So the Earth had an irrigation system in the ground that watered the Earth in those days.
That's right.
So all of that contributed to the Earth being flooded at the time we call the flood. I want to think about some of the ways that they can be changed. Our atmosphere is composed primarily of oxygen and nitrogen. About 20% oxygen, roughly 80% nitrogen, with traces of other things. If you look at the atomic structure of these two, there's only a difference of two particles between nitrogen and oxygen. Nitrogen has an atomic weight of 14. Oxygen has an atomic weight of 16. So if the nitrogen atoms were bombarded with protons and neutrons, they might be boosted up and converted into oxygen. We do all kinds of things with radiation these days, and we find some nitrogen is converted from nitrogen 14, which is its normal, to nitrogen 15. Nitrogen 15 is not a radioactive isotope. We say it's a stable isotope, and there's means to measure that the same as there would be to measure radioactivity from the other kind that give off electrons and so on. So there's a possibility for changes in the composition of the atmosphere. And let's say we have changes in the composition of the atmosphere. We have changes in the biological material. Everybody's heard of DNA, of course. And we get concerned about what might happen to DNA. We call it mutations, something that changes some component in the DNA so that it doesn't work the way it was originally intended. We call one type of change methylation. There are drugs, chemicals, environmental factors that cause little one-carbon methyl groups to attach to the DNA, and then it doesn't have the same shape. A methyl group's in the way that won't let it bond together. And this is one type. Another type is if something happens that a amino acid in a protein has a certain structure. It has some other amino acids that are almost identical to it, but not quite. And there can be substitutions of one amino acid for another, a mistake is made, and then this protein will not function the way it should, even if the DNA makes it. Okay, then aside from these chemical modifications that might change the shape or the reactivity, there are factors that will influence the body's ability to use the DNA that it has. Might find things that increase or decrease the amount of production of a given hormone or an enzyme. Let me give you an outstanding example. In young boys, they come to a point in life where something causes a change and they begin to secrete a substance called testosterone. And a boy changes into a man in a short time. So things can be modulated to turn on or turn off depending on circumstances. So we're looking at this sort of thing in terms of what can we measure that might show signs of this this augmentation or stimulation of new material. We think of changes in the atmosphere, the loss of the water, there may be increase in oxygen, increase in changes in carbon. So, as Dr. Ball said, it had been suggested that the snakes might produce different or show changes in venom if it was examined by taking it apart. We have venom composed of a mixture of proteins, and looking at this, we can separate those proteins by a laboratory method we called Acrylamide Gel Electrophoresis. It's almost like a foreign language. So this is what we did. As Dr. Ball described, we had litter mates, snakes that were born in the same batch from the same mama snake. Took one and just raised him under ambient conditions, our atmospheric and temperature changes as they occur. Then we took the other one and put in the biosphere, where we upped the concentration of oxygen about 50%, the normal 20% up to about 30%. We changed the atmosphere concentration of carbon dioxide. Just for interest, I looked up the average concentration of carbon dioxide in the atmosphere. We hear about greenhouse gases, carbon dioxide. Last year, the worldwide average of carbon dioxide in the atmosphere was 410 parts per million. Well, we raised it in the biosphere to 0.2%, which is about 50 times more than the atmospheric ambient conditions, if I did the math right. So they milked the snakes, brought the venom down. Our lab was at Baylor College of Dentistry in those days. Baylor has since merged with Texas A&M and got under their wing. But in our lab, we did research on lots of different things. And so we took this project on because these are techniques that we use in studying changes in dental tissues, and so on. So I have some slides that we want to look at that will show some of the differences that we found as we separated these venom proteins, and we took a glass plate and coated it with this gel. It's kind of like gelatin, and then we put it in a tray that had like a salt solution, a saline solution, and we ran an electric current through it, just a little low-grade electric current. We call it, it's a DC current that just ran in one direction. And this is what one of those plates looks like. And you can see the samples that are on here. We started at the bottom and turned the electricity on, and it migrated upward. And the protein spread out. We put a dye in the mixture, and it's the dye that we're seeing in these proteins. And you'll notice there's different intensities. I don't know if I can remember exactly which ones are which here, but on this one, just notice the difference. The band here, how much thinner. It's not quite in the same place, and it's a little thinner, and it seems to be missing over here. And I have a slide we'll look at in a minute that shows the names of some of these. Let me see if we go on, look at one more. One more. Here we go. And these were labeled on our master sheet to tell which ones were which. Here at the beginning there's a space where we used just salt water, and the next two were known standards, mixtures of proteins that we knew what they were, and the second one happens to be saliva as a sample. It's got several proteins in it, as you can see. 5 here is a copperhead under ambient conditions. He was raised under ambient conditions. This one was a copperhead under ambient conditions, and over here at number 7 was a copperhead under the influence of the atmosphere, and this little light one here is lighter than this one, and this one not too much different there either, but maybe this one will show a little better label so we can read the samples. Blank and a blank, and these were the two standards. Here's Copperhead Hyperbaric, and here's Copperhead Ambient, and look right in here, the difference, that one and that space. Go down here to the rattlers, the ambient, and here's the one. We have a copperhead at 2 different times. One was taken in January, one was taken in April, and notice the difference right in here. That one's a little thicker than this one. Get here, and by that time this one had disappeared completely, and there's a difference in this one in terms of intensity over this one. So some were turned on more than others, and some were turned off completely. Again, changes in time frame. We begin to see suppression of this after 4 months, and then on the copperheads, the changes were not quite so obvious, but we got a band here, no band here, and so we found evidence that the environment did make a difference. Those that were just at room temperature, whatever, versus those that were in the chamber. And so again, looking at the changes and things before the flood and after the flood, we can only use some of these indirect methods to get evidences of changes due to the change in our world.
Thank you.